Hi everyone, today's lesson is about limit of a function at positive and negative infinity, and I'm going to focus on three functions: polynomial, rational, and radical. So for polynomial function, if the degree of that polynomial function is even and the leading term is positive, the limit of that function as x approaches positive or negative infinity will always be positive infinity. For example, we have here x raised to 4 plus 3x minus 9. So as you can see, the highest exponent here is 4. And obviously that is even, and this is positive. So limit of that function as x approaches positive infinity will be positive infinity. Another example is this: x squared plus x plus 1. This is quadratic. And again here, the degree is even, it's positive, and the limit of that function as x approaches negative infinity is still positive infinity. And maybe you are still wondering why. Well, it's really easy to understand if you graph this too. So if you have a graphing software available right now using your calculator or a desktop, try to graph this too, and you will see that the ends of the graph of these two functions looks like this. So the left end, as x approaches negative infinity, it's going towards the positive infinity of y. The right end, so as x approaches the positive infinity of the x values, the right end is approaching the positive y values, also positive infinity. So that's why the answer is always positive infinity. Now, what if the degree is even and the leading term is negative? The limit of that function is equal to negative infinity. So for example, we have negative x raised to 4 plus 4x squared. So the limit of that function as x approaches positive infinity is negative infinity. Another example is this. So here again, the degree is 6, that's even, but the leading term is negative. See that? And the limit of that function as x approaches negative infinity is still negative infinity. And maybe you're wondering why. Again, my suggestion is graph this too, and you will see that the ends of the graph looks like this. So both ends are going towards negative infinity of y. Now what if the degree is odd and the leading term is positive? So the limit of that function as x approaches positive infinity is positive infinity. Example, x cubed minus 7. So that function as x approaches positive infinity will be positive infinity. That's the limit. So again, graph this too, and you will see that the right end of the graph looks like this, and the left end looks like this. So we're concerned about the right end because the question is the x is approaching towards positive infinity. The answer will be positive infinity. So what if the limit of that function or this kind of function is approaching negative infinity? The answer will be negative infinity. For example, here, so 4x plus 5, 4x is odd and it's positive. So here we just need to look at the left end of the graph, right? This is linear function, so it's a straight line. Slope is positive, so it's ascending. Look at the left end of the graph. It's approaching towards the negative infinity of y. Now, what if the degree is odd, but the leading term is negative? There are two possibilities or two answers here. It depends on the ends of the graph, obviously. So the limit of the function as x approaches positive infinity will be negative infinity. Example, x negative x raised to 3 plus x squared. Again, this is a third degree polynomial, and the leading term is negative. So as x approaches positive infinity, the answer will be negative infinity. So if you again look at the graphical representation of this, the left end of the graph is like this, right end will be here. So we're focused on the right end because question is as x approaches positive infinity. So as you can see, the y values there are going to be increasingly negative. Now, the limit of the function as x approaches negative infinity, on the other hand, will be positive infinity, as you can see in my illustration here. So the left end is going to the positive infinity of y. Example of that is this. So leading term is negative 3x raised to 7 because it has the highest exponent. 7 is obviously odd and it's negative. So as x approaches negative infinity of that function, the answer will be positive infinity. Now for rational function, there are three rules here. So the first rule is this. When the degree of the numerator is the same as the degree of the denominator, the limit is equal to the ratio of the coefficients, leading coefficients. Okay. So for example, x raised to 3 minus 2x plus 5 over x squared plus 4x raised to 3. The leading terms here are, for the numerator is x raised to 3. For the denominator is 4x raised to 3. Okay, those are the highest exponents in the respective places. So coefficient of x raised to 3 is 1. Coefficient of 4x raised to 3 is 4, right? So the answer is 1/4. So it doesn't really matter if it's approaching positive infinity or negative infinity, the rule still applies. So for example here, limit of this function as x approaches negative infinity, then look at the leading term on top, that's negative 2x raised to 3, meaning negative 2 over, in the denominator we have 5x raised to 3. So coefficient of that is 5, the answer will be negative 2 over 5. So rule number 2 for rational function. When the degree of the denominator is greater than the degree of the numerator, the limit is always equal to 0. For example here, again, you just need to look at the highest exponent in the numerator and highest exponent in the denominator. So the highest exponent in the denominator is greater than. See that? Greater than. 5 is greater than 4. Right? The answer there will be 0. Another example is this. Again, it doesn't matter if it's approaching positive infinity or negative infinity. The rule number 2 still applies. So here we have negative 3x raised to 4, which is the highest, which is the degree of term in the numerator. Here, the degree of term in the denominator is x raised to 5. So 5 is greater than 4. Limit of this is equal to 0. Now, for rule number 3, there are different variations. But here, the condition first is when the degree of the numerator is greater than the degree in the denominator. So this time, the one on top, the degree on top is greater than the degree in the denominator. So if the signs are the same, the answer will be the limit is approaching positive infinity. Okay? For example, here again, that's x raised to 3, that's the degree there. This is 7x, 3 is greater than 1. The answer will be positive infinity. Now, the limit of that as x approaches negative infinity, the answer will be negative infinity. That is if the signs are the same. If the signs are different, then it's going to be different, of course, the um, answer. But again, the condition is going to be the degree in the numerator is greater than the degree in the denominator. So the signs are different of the leading terms. So here we have a x raised to 4, and this is a negative x raised to 4. You see this kind of pattern? So the limit of that function as x approaches negative infinity is, positive infinity rather, is equal to negative infinity. Now the limit of the function as x approaches negative infinity, maybe you're thinking about the answer, and you're right. The answer will be positive infinity. So again, the condition here are two. If the degree in the numerator is greater than the degree in the denominator, and the signs are different. And of course, the question is the limit of that function as x approaches negative infinity. The answer will be positive infinity. So I think that's for the rational function. Let's go to the radical functions. Now for the radical functions, for example, x raised to square root of x plus 1, all you need to do is again look at the leading term. So here the leading term is 1. Substitute a certain number there, make it big, let's say 100. So square root of 100, 10 obviously. Make it bigger. So if you imagine substituting a certain number here and it's going to be really, really big, what do you think is going to be the output value? That is right. The output value will always be going towards positive infinity. And if you don't believe me, graph the square root of negative, the square root of x plus 1. And you will see that the right end of the graph is going towards positive infinity. Maybe you're curious. Now, what about the limit of that function? Same function as x approaches negative infinity. That's not negative infinity, that's 8. Well, again, imagine. So let's say negative 100. If it's negative 100, you add that to 1, that would be negative 99. Hmm, right? You add 100, I mean negative 100 plus 1, that's negative 99. What is the square of negative 99? That is right, it's undefined. So here, the answer will be does not exist. So meaning, when it comes to radical function, what you need to do is to pick the, look at the higher degree inside the radical sign, and then substitute a certain number and then think of what's going to happen. You can consider the entire function if you want, that's fine. I think it's better if you consider x plus 1, okay, or the entire function. Let's try this one. What about the limit of square root of negative x raised to 8 plus 2x as x approaches negative infinity? Again, you can consider both, but let's just try this negative x, negative 8x squared, raised to 8 rather. So let's plug in negative, let's just say negative 1. Negative 1 raised to 8, that will be positive 1, right? And this is going to be negative, okay? Now, if you consider that 2x, that will be negative 2x. If you add those two, that will be negative 3. So, hold on, that will be undefined. Let's make it bigger. If you make it a little bit bigger, the answer will still be negative. And the square root of a negative number is what? That is right, does not exist. So this one is does not exist. All right, let's consider the last example. Again, if you're curious about the left end of the graph, you might as well use a graphing calculator. Let's try this one. This is the last one. So what is the limit of this function as x approaches negative infinity? Again, you may consider negative x only, or you may consider 4 minus x. It doesn't really matter. But the strategy is pick the term with the highest exponent. Here is just x. So let's say negative 100 again, right? You substitute that to negative x, that'd be positive 100. And square root of that is 10, obviously. But there's a negative sign outside. So whatever the output value of that square root will be negative, right? So you plug in a negative number there, make it bigger, make it bigger, make it bigger. The answer or the output value will always be negative because of the negative sign outside. So meaning the limit of this function as x approaches negative infinity will be negative infinity. All right? So the best way is to check the graph. That's it. But if you're not allowed to do that, then use your calculator and try to substitute a certain number, make it big and make it really big so that you will see the output. Okay? So that's it. Thank you for watching. You have a good one. Bye.